right then. Thanks for answering those. And with that, then we'll just go over just a quick agenda of what we plan to cover today. So we'll get started with why do we need to, what's the purpose of like this whole session really? Why is it really helpful and beneficial to model the data? Well, with RudderStack, but also mainly using DBT models. We'll get into like what are some of the DBT models that were created and mainly focusing on the topic of identity stitching. So we're going to go through the different steps in which you can build those models yourselves as well. And then lastly, we'll talk about what are some of the next steps once those are built out and just some best practices to keep in mind. And like always, like definitely opening it up for like a question and answer session. So, but definitely don't wait till the end. Like if there are any questions that you think about while the topics are being presented, definitely make sure to use either the chat window. We'll definitely answer you there, provide any links and any useful resources, but also you can feel free to unmute as well if there are any questions that you have in mind. So as always, we love to always get started with just a brief introduction to what RudderStack is, because based on the poll that we've seen, there are a few of you who may have just discovered it. So usually we love to, again, start off with an interview of the RudderStack, an overview of the RudderStack architecture. And so if we think about like RudderStack in general as a product, it's an open source customer data infrastructure that is warehouse first. So at its core, you've got three different types of pipelines that are supported. We start off with, and usually that's where most folks start off with, is with event streams, in which you can set up SDKs within to send data from your web, mobile, or server-side applications directly to any downstream destinations and tools, but also to your data warehouse. So really centralizing that to your data warehouse, which may either be BigQuery, Snowflake, Redshift. So really the idea here is to not persist any data, but rather use your own data warehouses and send the data directly to them. So in addition to that, there's the second kind of pipeline, which is just a traditional ETL batch load pipeline that enables us to set up a source from our CRM tools, our marketing tools, marketing automation tools, to send that data directly and centralize it with the data warehouse. So along with our ETL data and our event stream data, we can kind of form a full picture of the customer and whatever activities, whatever actions are being captured through the event streams as well. So with that, we can then use the data warehouse to build audiences, build models, and then activate those back, send those models to downstream destinations for them to be activated and actually utilized for marketing automation tools and campaigns and so on with reverse ETL. So really, it's a combination of like data movement pipelines, but at the core, it's warehouse first. So it's really all about centralizing all that event data within the data warehouse and unlocking multiple use cases from that. So really, that's, again, which leads us to the topic that we'll be discussing today. And I'll hand it over right now to Benji to kind of walk us through how we can perform identity stitching directly on our data warehouse. Benji, just feel free to share whenever you're ready.
There we go. Thank you, Sarah. So, as Sarah mentioned, my role as a solutions engineer here at RudderStack is working with customers and really trying to get the most out of their RudderStack implementation. And for, in its simplest terms, that means like doing something with the data in the warehouse. And so a lot of our customers use DBT to transform data, to model data, to schedule jobs in their warehouse. And here's just a brief slide on DBT. Some of you may be existing DBT customers already. If by any chance any of you are going to the DBT Coalesce conference in 2 weeks, RudderStack will be there, and I will also be there. So if you'd like a hands-on demo of kind of what we're walking through, be sure to stop by our booth. So real quickly, this topic is focused on identity stitching, and I we created this slide to sort of just differentiate briefly between identity stitching and identity resolution. And when we talk about identity resolution here at RudderStack, what we typically mean is really um, identifying anonymous activity from first-party cookie data. So with RudderStack SDKs, uh, we have a persistent anonymous ID that will flow through to your warehouse with all of your page and track events. And then at some point, if you submit an identify call, because you now have a user ID, an email address or user ID from an app or sign in or whatever, um, actually in the warehouse, combining the anonymous activity with that now known user activity is really important, and that sort of we can do out of the box. When it comes to identity stitching, this has to be done in the warehouse. And again, as Sarah highlighted earlier, we have event stream data that has anonymous IDs and user IDs and emails, but we also have ETL data from our cloud tools, which may not have, those exact same identifiers. But then you might also have other data in the warehouse that is ingested through other tools or archived there that wasn't actually touched by RudderStack at all. And so identity stitching is really about connecting all of those data points and building a unified kind of identity for a user. And so kind of why this is important for us at RudderStack and for our customers is that identity stitching is really kind of at the foundation of enriching and empowering your CDP. So to kind of build a unified user in your warehouse means we can now do things like build a full feature user journey across the entire customer experience within our warehouse. It means we can also take that user journey and build a feature store on top of it. And then we can kind of take that feature store and build a customer 360 or golden record. And then lastly, use tools like RudderStack's new audience builder tool to kind of reverse ETL audiences and audience segments into our other SaaS tools or BI applications. And so these are all topics for future office hours. So let's kind of get back into identity stitching. And so when I think about identity stitching, it's really like playing a game of dominoes, or to be honest with you, at least how I know how to play dominoes, which is basically to connect, matching endpoints. And so like a tile on a domino that has kind of two sides of dots, we can think of data, any row of data in our database or our warehouse as kind of this tile. And what we want to do is identify, like, hey, do any of these rows have two sides? Do they have two identifiers or two nodes? And so if we have a row of data that has an anonymous ID and a user's phone number, or an anonymous ID and an email, we can start to kind of connect these different points to create a graph in our warehouse. And so kind of walking through how we do this with SQL and how we use dbt to sort of expose this is kind of what we're going to cover next. So if we imagine this is a very simplified version of data in our warehouse. And so like with a typical RudderStack use case, we'll have page calls, track calls, and we might have some server-side events or ETL events from Shopify or Stripe or any e-commerce system. And so within our tables, we have anonymous ID, user ID. We might have a context traits email or an email property. And what we can see from these that, not all of these values are populated, but we have different values in each of these things. And it looks like these are, a bunch of different users in our warehouse at first blush. But if we consolidate all of these into sets of key pairs in our edges table, we can see that, okay, we have anonymous ID, and a Gmail address. We have a different anonymous ID and a different email address. And we can start to kind of see how this lines up in this edges table. And we're going to just randomly assign an identifier to all of these. And then kind of the goal of this is to go through and consolidate our edges. And so we can consolidate edges in the same column like we're doing here and reducing this rudder ID, or we can consolidate edges in on the other side. But then we can also consolidate edges across our table. And we're going to walk through the sequel of this in just a second here. But you can see as we kind of recursively go through this, all of our edges across and up and down get consolidated to now we have a single common rudder identifier for all of these different edges. And that, if we build an ID graph means, right, we now have a single rudder ID. And now we have all of the distinct edges. And then we consolidated our labels. And again, this is just sort of contextual metadata to help us understand, all right, where did these identifiers come from? So let's kind of walk through the DBT package that we use. And so when we look at, and so feel free to check out DBT Hub's Rudder Labs packages, and we'll also be kind of introducing some new packages at Coalesce. We're going to be using the ID stitching package here. So there are kind of 4 different models that we've created here. A queries model, an edges model, and a user ID graph are kind of the 3 key steps in this. And then there's a check edges that we'll talk about kind of towards the end. And that's really just to define whether we need to kind of run our incremental model further. The queries model, as we'll see, generates the edges, and then the edges model goes through and kind of recursively goes through and refines and looks for those common edges and common pairs and does the consolidation. And then the ID graph, as the name implies, generates the ID graph table sort of at the end. With any DBT project, probably kind of you always want to look at the project YAML, because this is kind of where you set the foundation. The key points in this model are that we are going to define some variables, and these variables flag the ID columns that we want to use. We can also define identifiers that we want to exclude, and this will become a little more clear in just a minute as we kind of get into the weeds. And then there are also some additional variables that we've defined, like schemas to include, schemas to exclude, tables to include, and tables to exclude. And we'll kind of get into those more in just a second. So looking at the first model, our queries model, really the goal of this is to look in the information schema, or in this example came from Redshift, which uses the SVV columns table. And what we want to do is look for our identifiers. And I've hard coded these for this demo. But in the project, we're just going to pull these column names and table names from our variables. And so in this example, we want to look for anonymous ID, user ID, email, and context trace email in these RudderStack tables. And then we're going to look for certain stripe identifiers from these stripe tables. And again, you could do this all within the variables, or you could kind of hard code these if you kind of know where to look for them. And when we execute this SQL, what it does is it produces the column name. This just produces a list of column names, and the database schema and table names where those columns are present. And so if you're just getting started with RudderStack, or you have a fairly small data warehouse, you might know this, right? But as your enterprise expands, as your stack expands, as we start to incorporate more data, you may not know where the email or customer ID or order ID, where all those columns are present. And so this is a good first step to just sort of evaluate, hey, this is where we think all of this data exists, and is any of this redundant, or do we want to do some cleanup ahead of running the script? The bottom half of this first model, so this was a CTE up here to kind of generate that list, and now we're using a fairly simple select statement, but joining that CTE on itself, because what we want are pairs of these identifiers. Remember, our edges table consists of 2 nodes, and those 2 nodes means that we have 2 identifiers for a particular user in the same record of data, like an anonymous ID and a user ID. And so what that does is it creates a SQL statement that looks kind of like this. So we want an email address, the email value, and we're going to convert all these to text because we're going to join all these in a single table. And then we're going to stamp the value email as our label. And then we're going to do the same for the B side. So we have an A side and a B side, and an A label and a B label. And it's important to note that we only want records where both of these values are present. If we only have an anonymous ID and no user ID, or an email and no customer ID, then that, like in the game of dominoes, you just end up with a terminus in our graph, which isn't very helpful. So once we have those SQL statements, we now kind of jump into our edges. And this edges model, we're going to mode 2 ways. The first time we run it, we're going to run it in full mode, because we actually want to create the full table of edges. And so you'll see we have this configured for an incremental mode. And when you define an incremental mode, that means you're just going to make updates or upserts. And we're using our original rudder ID as our key. And so for the first full mode, where this is not incremental, we use a standard DBT utils, and we can get more into the DBT utils into the Q&A section. But we're just taking those values that we ran before in our RS queries and just joining them all together with a union separator. And then also, you'll notice down here that we are going to, if we had any values that we wanted to exclude, and so if we have test email addresses or internal users that we want to exclude as any values in our edges table, we can define those here. And of course, we want to define them across both edges. And so what that looks like is this SQL statement where we're looking in each of our tables where we have our identifiers, and we're just, again, building pairs. And so like for our Stripe invoices table, you can see that we have multiple different select statements that account for all of the iterations of those key pairs. And so in our warehouse, what that does is it produces a table of unique identifiers and their labels. And at the start, we have an original rudder ID and a rudder ID. And as we kind of go through this, you'll see as we start to match, we'll just update our rudder ID with the lowest available rudder ID. And so when we run the model in incremental mode, and I've for the sake of screen sharing, truncated out the CTE min edges here, so that's available in the code. But really what we're trying to do is go back and for any combination across edge A or any matches across edge B, find the lowest rudder ID. And then anywhere else where the rudder ID is greater, we want to replace that rudder ID with the lowest original rudder ID. And we do this across edge A, and we do this across edge B, and then we find the absolute minimum of each of those and then apply it back to the other side. And so because of that, we want to run this incremental mode multiple times. And how many times you have to run it really depends on how many different source tables you have, how many different identifiers you have. But usually 3 to 4 times is sufficient. And that's what the check edges model is for. It's just a view that evaluates the where clause that you see down here. And if you're running this in a client mode, for example, or from a Python script, you can create a for loop that says, hey, if this needs to run it again, run it again. If not, go to the next step. Also want to highlight that in our DBT model, rudder ID is just an auto-generated row number, but certainly if you wanted something that persisted, you could replace that with the first known anonymous ID or first known user ID, or if your warehouse has kind of an absolute unique user identifier, you can reset that either in the edges table or in the ID graph itself. And so here you can see the output where we've now consolidated all of these rudder IDs to the lowest common identifier. This is another example where we're actually using order numbers, cart tokens, order IDs, and persisting data from client side, email, and server side events. And then so the last step in this is generating the ID graph. And the goal of the ID graph is to kind of output a real table that can be used as a lookup for really any other data in your warehouse, and then consolidate or join or group or aggregate or whatever that data based on this, now unified rudder ID. And I put any in quotation marks because obviously this is sort of any applicable data, not any and all data in the warehouse. You could materialize this as a view if you wanted to, but for performance reasons, I find that actually generating a table in the warehouse just makes it easier and faster to run queries. And essentially what we're doing, again, is taking the A side, taking the B side, and just consolidating it to kind of a single definitive set. One application that we've found a lot of customers doing is actually not just using the column name as the label, but using the full database schema table column name as the label itself. And you can see in this example that it is a lot of detail here, but this is really useful when it comes time to kind of understand, well, where do we have PHI or where do we have user data in the warehouse? And so if you're doing an audit, this ID graph is a useful tool for understanding, okay, where do we actually have this email address? And you might think, oh, well, we've got it in our emails table or our RudderStack identify or users table, but we can also see that there's some underlying iterable tables where this data exists. And while we're at it, let's go ahead and flag all of the activity, even for these anonymous IDs. And so that's kind of a very useful trick in our ID graph. So a couple things to consider when we're building out these models. We touched on this earlier, which is, how many times do I need to use the edges incremental model? And that's really why we have that fourth model for check edges. It's, again, just the same logic, but it's created as a view and with a true false of, do you need to run the model again? And then an integer of how many edges there are to consolidate. Another suggestion is to start with as few identifiers as possible. And so, again, we talked a little bit about identity resolution earlier. And that would include like just anonymous ID and a user ID from your RudderStack SDK events. But extending that just to email or context traits email, that's kind of how we have it configured out of the box. And that's a great place to start. Avoid using IP address, business phone numbers, and other domains. Those are not uniquely specific to a user or to an identity. And of course, we could have a whole nother session on the definition of an identity, but for the sake of this sort of conversation, we'll just assume that an identity is a user or DNA. On the other hand, it is okay to use distinct child values or child records like order ID, subscription ID, cart token, and things like that, as long as those values are unique. Along those lines, if you want to build additional models, and the goal of this is you can build user-specific models, but you can also build account level or product level or other aggregate level models. And so if you include data points like CRM account ID or email domain or business phone number, then as an identifier, then your anonymous IDs, user IDs, emails, and if you then include those business phone numbers or email domains, all of that data will roll up to kind of the most common denominator. So it will roll up to a CRM account ID. And so if you're building user journeys or feature stores, and you want to do that at an account level, say if you're a B2B entity, that's a great way to model data and then derive user journeys and user features at an account level while running the same exact SQL against a different model at a user level and kind of having user level features and then account level features. And then lastly, we talked about it a little bit in the DBT project YAML, but the include and exclude variables are very handy for refining the number of tables, refining the number of schemas that you want to use, and then also kind of removing, bad nodes or bad edges because of dummy or test data. And, as you go through this and start to experiment, you'll see that, sometimes people have hashed email values that are literally the expression hashed email and not an actual hashed email. And so if you have kind of bad data and bad identifiers that persist across multiple users, then those users will all get consolidated together because it thinks an ID is an ID. And Sarah, I think we kind of wanted to open up to questions and answers if there are any.
Yes, of course. So yeah, any questions on anything that Benji covered? Or anything related to like identity stitching, or really not identity stitching. It could be like anything related to RudderStack. I actually did have a question, Benji. So those packages, which we I put a link in those in the chat, by the way, for the identity stitching package, both in GitHub and in the DBT hub. But one question I have is, Are those like applicable for all data warehouses? Like, can you maybe share a little bit about that? Like, or like, can it be applied to Snowflake, Redshift, like, or is it mostly intended for certain types of data warehouse or certain vendors?
These, the beauty of DBT is that DBT, and we highlighted a little bit about the DBT utils and the DBT macros. DBT's kind of number one goal is to allow developers to create code and write SQL that is kind of warehouse agnostic. And so DBT, you can run the same DBT package across different warehouses, whether it be Snowflake, BigQuery, Redshift, Postgres, Databricks, and I'm sure there will be more after the Coalesce conference, because they always kind of announce new things. And one thing, like when I first got started with DBT, I literally just copied and pasted my SQL queries directly out of my SQL Workbench tools, pasted them into a model, hard-coded table values and all, and just used DBT as a scheduling tool. And then once I became more familiar with DBT and kind of how to use models and how to use the DBT language, it really kind of opened my eyes as to the power of DBT. And so the DBT macros and DBT Jinja are really great, and allow you to kind of run the same set of SQL on any warehouse. One exception to that is, like, in our IDs teaching, in our queries model, we use the SVV columns table, which is a different table in Redshift than the information schema in just about every other warehouse. And so that was hard coded because we just didn't build an adapter yet for this model. But that's kind of the only nuance that I've found so far.
Awesome. Yeah, that's great, Benji. And it's good to know that it supports like all of them, so it can be used really with any type, with any data warehouse. I see there's another question in the chat from Chris, which is what happens when there are multiple user IDs to one anonymous ID with this model?
So assuming we still want to use user ID, those would all get consolidated to the same rudder ID. And so if we had, like, let's say we had a user who was logging into, like, maybe a QA instance and a prod instance, or logging into Salesforce. That's probably a bad example, but Salesforce uses a different sandbox username. But the models, the way the model works now is it looks for any common identifier. We have worked with some customers who have tweaked the model to make the joining in the RS queries based on both the edge being the same as well as the label. And so in future iterations of this model, instead of using the column name as a label, you can also pass an alias to the label. So if you wanted to kind of make everything be an email address and say, well, only stitch email addresses that match, or only stitch user IDs that match. So that would be like, if you did not want those user IDs to persist, you could do it that way.
Sounds good. Chris, hope that answers your question. If not, feel free to let us know in the chat or unmute if you want. But feel free to keep adding questions if you have any. I'll just go over kind of some additional resources now that before we wrap up. So there are a couple of blogs that we've written actually around how we can use different DBT models, maybe for customer, if you want to do some customer session analysis, you want to analyze multi-touch attribution as well. There are a few that we actually have blog posts on, so you can check those out, and I'll link those in the chat as well. I've also linked the DBT package hub, but that's also within the chat. Also linked a number of getting started videos, whether it's for whether you're getting started with the open source product or with cloud. They have a number of series on walking through the product, an overview, and some of the main features, the core features and functionalities. And then we also have some short how-to videos which you can check out, which tackle very short. They're very short snackable videos around certain product features, so you can take a look at those as well. And again, we those office hours are very community based. So if you have a topic in mind that you would like for us to discuss or talk about in an office hour, make sure you let us know by first joining our Slack community if you haven't already done so. And we have a specific channel called Community Office Hours where you can go, and we launch polls regularly on those to kind of get an idea of what are some topics of interest. And just to kind of go briefly over some upcoming events, we do have an event coming up, a webinar around exploring Google Analytics 4 options. So we're going to be talking about different implementation options for Google Analytics. So you can register for that. It's going to be in October 12th. And coalesce. We're going to be there. Feel free to, if you're going as well, join our booth. You can also meet Benji in person. If you have any questions, you can ask him in person as well, since he will be there. We are also hosting a happy hour, so make sure to join that as well if you're going to be attending the conference. So with that then, thank you so much for attending with us today, and hopefully we'll see you in the next one, and have a great
the rest of the team on how to approach them. Let's have those conversations.
Thank you, everyone.
Thanks, everybody. All right.